Hi, welcome to Physics 4A. My name is Alan Nickel. I'm the instructor for the course, and I'm really looking forward to the semester. I really enjoy physics, discussing physics with students, and so I think we're going to have a lot of fun this semester. Um, the video that we have here, I'm going to be, in a minute, going through the syllabus for the course and taking a look at the schedule of the course, kind of outlining the structure of the course, what we're going to be working from. I do want to go ahead and get started with showing you a copy of the textbook. The textbook we'll be using for the course and for Physics 4A, 4B, and 4C, all three semesters, is Physics for Scientists and Engineers with Modern Physics. So there's 44 chapters inside here, and by the time we've completed all three semesters, we will have gone through all 44 chapters. So what I want to do now is, oh, here's the rest of the book. This is, the author is Gian Colli, and so that's the textbook that we'll be working from for the semester. So let's go ahead and take a look at the syllabus and the schedule for the course. Welcome to Physics 4A. So what we want to do to get started with the course is we want to take a look at the syllabus and the schedule of what we'll be doing during the semester, and then I'll also show what a homework set looks like. And so welcome. Again, my name is Dr. Alan Nickel, and these are the topics of Physics 4A. So we're going to start out looking at kinematics. Now, kinematics is kind of a way of expressing, kinematics has to do with motion. So it has to do with displacements and velocities and accelerations and being really clear about how those are all related. And that's what we're going to start off with, is kinematics, velocities and accelerations. We're going to show that those accelerations are related to the forces acting on objects. So we find out that the forces, if we add up all the forces acting on an object and find out what the net effect of all those forces are, that can be directly related to the acceleration. Not the velocity, but the acceleration of the object. And then we take a pretty detailed look at gravity. We look at energy and momentum, which are important concepts in physics and in engineering, in the sciences in general. And we find out what is energy. When we talk about the energy of a system or the momentum of a system, what is that referring to? After that, we take a look at rotational dynamics. So rotational dynamics, there's a lot of really surprising, interesting kind of things that happen when objects are rotating compared with when they're in linear motion. So that turns out to make quite a distinction in how the objects are behaving. And then once we're through rotational dynamics, we're going to be looking at the physics of fluids. We're going to be looking at oscillatory motion, which is keeping track of objects that are in motion, kind of repetitive motion back and forth. And then that leads into wave motion. And then finally, we'll finish up the semester looking at sound. So it's a great set of topics. Physics 4A is a really fun course, I think. A lot of really interesting items that we're going to come across. So let's take a look at that syllabus. And I'm going to say that this is the syllabus here on the left side. Now the syllabus, the homework set, the schedule, they're all posted to Canvas. So if you're watching this, I think it's in a Getting Started module, something like that. Kind of the first module right at the top of the modules. And all of these are posted there. So you can follow along either directly from the video, or you can just take a look at the, you can look at the PDFs that have been posted onto Canvas. So again, here's the syllabus. My name, Neil Alan Nickel. There's an email address where you can stay in communication with me. Office hours are on Monday and Wednesday, so it's the hour right after class. So on Mondays and Wednesdays from 9 to 10. And then also later in the day on Mondays and Wednesdays from 12 until 1. So those are kind of my official office hours. Now you're also welcome to stop by during any of my lab classes. So if I have a lab going on, you can stop by, and I can usually free up some time and we can take a look at what questions you might have. So as far as lab sections, the lab sections for Physics 4A, those are on Fridays from 9 to 12 and from 12 until 3 p.m. And then on Wednesdays, I also have another lab section for the Physics 4C class that I'm teaching, and that's on Wednesday from 1 until 4. So it'll all be posted. It's on the door of the physics lab room, A274. And so you can go there and take a look at the schedule. And hey, if I'm around on campus and I'm not in a classroom somewhere, chances are that I'm going to be in the lab room A274, and you're welcome to bring questions there. Encouraged to bring questions there so we can get those questions taken care of. Now, the lectures, or the textbook rather, or the prerequisites, jumping ahead a little too quick here. The prerequisite for the course is Math 3A. You're supposed to have completed 1 semester of calculus. And yeah, we'll be using calculus definitely in the course. Now, it's not like calculus shows up in every example that we look at. So especially at first, calculus will show up, kind of intermittently. What you really want to be solid on is you want to be really, really good at algebra and trigonometry. Now, not all of trigonometry, but the part of trigonometry that specifically gets used in physics. So now, once we start getting into, not so much chapter 1, but once we get into chapter 2 and 3 and beyond, you'll start to get a feel for what particular items from trigonometry are going to be required. And as I said, right from the start, everything's going to require algebra. So it's a very good class for practicing those algebra skills. So if you've got the skills in place, that's great. If you're a little shaky on some of your algebra skills, this is the place to practice those. Every example we look at is going to involve algebra. And again, getting back to the calculus, that's going to show up, but that's more intermittent, where we will be using calculus in a problem. The textbook for the course is Physics for Scientists and Engineers with Modern Physics by Giancoli. So you have to be a little careful here, because kind of every physics text out there has almost the very same name. So ours specifically is Physics for Scientists and Engineers by Giancoli. We're still using the 4th edition. Now, a 5th edition came out just a few months ago, so this is pretty recent. There is a 5th edition available, but the 4th edition has been used very broadly. And so there are plenty of used copies of the 4th edition, and so I think that's a perfectly reasonable approach, is to go ahead and keep using the 4th edition. So once you've gotten the textbook, the Physics for Scientists and Engineers, that's going to include not just the 16 chapters we're talking about here for Physics 4A, but it will also include all the chapters for Physics 4B and Physics 4C if the textbook you get has the With Modern Physics. So if you intend to take the entire, if you're required, to take the entire 3-semester series, 4A, 4B, and 4C, then probably makes sense to go ahead and get a full textbook. Now, that full textbook will have 44 chapters. And so by the time we're through Physics 4A, 4B, and 4C, you will have gone through all 44 of those chapters. In order to make sure that those chapters are there, you've got to get the versions that include modern physics. That will be part of the title. Any questions on this too, just let me know what questions you have. So moving on from the textbook, the lectures that we have Monday, Wednesday, Friday, 7:40 a.m. to 8:50 a.m., those are going to be in room A266. The labs that we have are on Friday afternoons after class. Now, there's a morning lab section and there's an afternoon lab section. They're both in the same room, A274. And what I find with the lab sections is students kind of shift back and forth. So I know that for some students, they can only take the morning section. And for other students, they can only take the afternoon section because of their schedules. But often I'll find that, most students can come to either one. And, after a few weeks, sometimes students try out morning and afternoon. What often happens is study groups will tend to form. So, what's often happened in the past is that I will have groups of students that form a study group, and then on Fridays after class, they'll go to the libraries, for example, and work together on homework problems, and then they'll come back into the lab room at noon for the lab. In any case, I'm going to provide some flexibility here and tell you guys that you can kind of try out morning or afternoon and see which you prefer, or which study groups or lab groups you seem to connect with. For the homework, there is going to be an assignment for each chapter, and there it is. That's the homework handout right there. There are the 16 chapters that make up Physics 4A. They follow the topics that we just looked at on that front page. As you can see, there's a set of homework problems assigned for each one of those chapters. Now, it's not just the homework problem. The homework problems are very important. But leading up to the homework problems are going to be the examples that we look at in class, and then also the textbook has examples within the chapter itself. So textbooks have gotten so good with this, so rather than having students go a whole chapter, and then at the end of the chapter, then they throw a bunch of homework problems at you, what they do is they give you examples throughout the chapter. And so those are very useful if you're working through the textbook, for example. What you can do is you can stop, you'll read a couple pages, and then they'll give you some examples to think about and some story problems to set up and see if you can solve those. So those are going to be important. The examples we look at in class are important, and the homework problems are important. Now, often students, as much as time permits, spend time on these homework problems. I often tell students, if you've gone through a homework problem once, and you've kind of struggled with it, and you've worked through it, and you now have managed to get all the way through the problem, it's such a good idea to go back maybe a couple days later and start from the very beginning again with no notes and see if you can get through the problem. Okay, so that really helps to reinforce as you work and rework the homework problems. Now, I understand that there's only so much time available to put into physics classes because you've got other classes going on and work and other things, but as much time as is practical to put into the homework problems and examples, you'll find that when you go back and you rework problems, things make a lot more sense each pass through those examples. All right, so there are homework examples that are given right here. The labs, it's important to be in lab and participate. In lab, you will be in lab groups. So you'll be working with, maybe, 4 or 5 people in a lab group, and 3, 4, or 5, let me say, in each one of the lab groups. And you want to be working together. So the idea of the lab group is that you're going to be catching each other's mistakes. You're going to be discussing the lab and thinking about what's the best approach. How can we come up with the most reliable set of measurements, and how can we carry out the calculations so that we have the most reliable results by the end of the lab. So that's always going to be our focus in lab. And again, you'll be working together with a lab group for that. Now, I've got the midterms listed here. We've got the schedule that we're going to take a look at in just a minute. But just to set this up, we've got 4 midterms scheduled, and that we have the dates. These should all be Fridays. So on Fridays, when we have the midterms, we won't have labs on those days. And what we want to be able to do for the midterms, the class itself is like an hour and 20 minutes. And what I like to do for the midterms is provide some extra time. So in the past, we've tried different things. Sometimes we can get the class to come in a little bit early for an earlier start on the midterms, or else we can extend it out into that morning lab section. But we'll figure out a way to make sure that we've got some additional time for the midterms. The final exam is scheduled for December 16th. Again, it's a Friday, and that's comprehensive. Now, as far as the grading, let's go ahead and look at that. So the grades, we've got the midterms, we've got the final, and we have the labs. Now, the midterms, there's 4 of those, and a lot of times students are used to this idea of, oh, I can drop a midterm. But I don't. I actually don't allow students to drop a midterm. And I've tried that in the past, and my experience has been that I just think it's important to make sure that you understand each portion of the course. So I don't want to drop any of the midterms. So if an absolute emergency comes up and you're not able to attend one of the midterms, let me know as soon as that is happening. Sometimes in advance, students know because of some scheduling conflict that they're not going to be able to attend a midterm. So if possible, let me know in advance. But as soon as you know you're going to be missing, let me know. And we'll figure out a way to do some kind of a makeup. But again, this is reserved for an emergency situation. Falling behind in the course is not considered an emergency. In fact, that's probably something we should talk about right now is, what are the real strategies for being successful in a course like this? And the general physics series that we're looking at here, Physics 4A, 4B, and 4C, these are pretty high level of commitment. There's a fairly good high level workload for these kinds of courses. So I always tell students, the most important thing is to stay caught up. So right now, you're looking, this is the beginning of the semester, we're looking at those first chapters. So don't say, yeah, I'll get around to chapter 1 maybe next week sometime. Get started with chapter 1 right away, and maybe get a start on chapter 2. So if at all possible, try to stay a little bit ahead of the game, rather than trying to always play catch up. And that way, the lectures are going to make more sense. If you're staying caught up, the homework problems are going to make more sense, and don't plan on being able to do all of the catch-up the night before the midterms. Okay, it's kind of an impossibility, I think, to just start right there and try to get prepared for a midterm the night before. So really, there's this first midterm coming up September 16th, and I would say get out a calendar and start identifying blocks of time that you can set up. Say, this is my Physics 4A time. This is when I'm going to be working on Physics 4A. So here are the 4 midterms. So of the total grade, the midterms are going to make up 60%. Now what that means is each one of the midterms individually is 15% of the course. And that's it's a pretty good sized amount, and the idea there is that's an incentive to make sure that you're staying caught up through the semester. And it's not like I'm going to wait till the final exam and then some kind of a miracle will occur. So get in early, do well on those first midterms. Okay, students that, Physics 4A, students that do well on that come prepared, let me say that, students that come prepared for the first midterm, they finish the course successfully. Okay, and so it's these next 4 weeks leading up to that first midterm are going to be crucial. So you want to make sure that you're putting time in, and I'm going to say these chapters are entirely doable, but it's going to take some time. So it's going to take, again, a commitment of diligence and effort and whatever. If questions come up, let me know. So we can always, whenever the questions come up, let's get a look at those problems and see if we can make sense of them. Now what's so the final exam is 20%, And then the labs collectively are 20%. Now, if you take a look at the labs, I think there's like 12 labs during the semester, something like that. Now, I don't drop any of the midterms, but I do drop one of the labs. And that's because what I find is with scheduling conflicts, often, you know, many or most students in the class at some point in the semester are going to end up missing a lab. Just because of scheduling issues that come up. And so I do drop one of the labs. Now, of course, I encourage students to come to all the labs, if at all possible, but if something comes up and you end up missing a lab, you can think of that lab as the one that's going to get dropped. Let's see, 60%, 20%, 20%, that all adds up to 100. Now, at the end of the semester, what I'll do is I'll weight the scores on the midterms, the final, and the labs, and I will use that 60, 20, 20% weighting system, and then we'll see where the numbers are. So if you've got 85 to 100, you're in the A range, 70 to 85 is in the B range, and 50 to 70 is in the C. Now, sometimes students go, wow, that's a pretty lenient grade scale. Maybe you're used to a class where you know, a C requires 70%, a B 80, and an A 90. But I think what you're going to find, if you're a science and engineering major, which you guys are, what you're going to find is in your science and your engineering classes, very, very commonly, you're going to see grading scales more similar to this. There's just a tendency to maybe make the exams and the final exams and the midterms a little more challenging, and then lower the grade, the percentage requirements. And what that allows us to do is kind of spread the class out more, so it's not like everybody's getting up in the 90%, that there's more of a spread. And you know, if you're through the course and you have successfully completed, you know, 50% of everything we've looked at, you're going to find out that that's fairly substantial. So passing the course requires that you put some effort in. At those higher levels, those are going to enable you to get a B or possibly an A in the course. Now, what also happens at the end of the semester is what I will be doing is, it's what I call curving the grades a little bit. What I'll do is at the end of the semester, those boundaries between the A and the B's and the C's are going to drop just a little bit. So I'm going to say this, if you get all the way through the semester and everything averages out to be an 84, chances are you're going to get an A, all right? So these will drop a little bit at the end of the semester. But what I always encourage students to think in terms of is don't think in terms of that, think in terms of this grade scale. Okay, and then at the end of the semester, if you haven't quite made the cutoff for that grade, if you can come within a point or so, chances are you're going to get that higher grade. Okay, a little bit of curving at the end. The homework problems we talked about. Let me move on to the next set of handouts here. This is the schedule for the course, and we stick with this pretty closely. So if you take a look at Canvas, so I'm guessing, well, you're watching this, so you must have found Canvas. If you look through all the modules set up on Canvas, what you're going to find is that thanks to the pandemic, back when we were teaching remotely, I put together a complete set of lectures, both for the lecture part of the course, and then I also put together a complete set of lab activities. So the lectures were recorded mostly here in my garage, and the labs were recorded actually at the lab room here at Laney College, or there at Laney College. And so for the for the lecture videos, I prepared a set of notes. There's a video that you can watch, and you can follow along with a set of slides that go along with those. So that was pandemic. And now we're not in that mode now. So these courses, the Physics 4A course, is an on-campus, in-person course. But if for whatever reason an emergency comes up, if you end up missing a couple of weeks, I mean, there's still COVID restrictions, so if you test positive for COVID, you're going to be asked not to come back to campus for a week or so. But what this is going to enable is if emergencies come up where you're not going to be able to be in person, you can refer back to those lectures and those labs that have been posted. So you can take a look at these if you want. So if you take a look at the modules in Canvas, I think right at the top we have the Getting Started, which is what we're doing right now. And then if you scroll down next, there's an Office Hours module. And so and this could happen during the semester. It could be that I have office hours through Zoom, through ConferZoom. And so if I do have office hours that I want to hold remotely, I will post those links in the office hours links section. So that's where you would be going if you were coming into remote office hours. And then if you continue through the modules, you'll see chapter by chapter. So I've organized the modules by the chapters in the textbook, and then for each one of those chapters there's going to be 2 or 3 or 4 lectures that go along with that, as well as a set of slides that you can follow along with. If you get all the way down, you got to scroll quite a ways down. If you get all the way down past those 16 chapters of lecture, you're going to run into the lab modules. And so for each one of our labs, again, I have these videos that I've taken in the physics lab room here at Laney College, or there at Laney College, of me, first of all, giving a presentation, an overview of what we're doing in lab for that day. And then that video continues to show me setting up the lab equipment. I'm your lab partner for these. I'm setting up the lab equipment, and then I'm going through the measurements, and then I'm running through examples of what the calculations will look like. Okay, and that was kind of pandemic mode for these courses. Again, this course is on campus, in person, but if emergencies come up, where individuals, or if the emergency comes up that the whole class has to go remote. I noticed I keep getting these emails telling, from the administration, reminding instructors that they have to be ready to go remote if needed at any instant during the semester. So we're good to go with that. Everything is in place. We can go back to remote if that becomes necessary. As far as the schedule, we stay pretty much on schedule. So I've got the 16 weeks of the semester mapped out here, and the 17th week is finals week. If you'll, go back to that syllabus, you'll see that there is a midterm after 4 weeks. There's another midterm after 4 additional weeks. So every 4 weeks, there it is, midterm 3 and midterm 4. Holidays are listed on here. We've got Monday, Wednesday, and Friday lectures, and then within each week it will tell you which lab we're doing. So if you want to look at the labs in advance, they're on Canvas. So you can take a look at presentations for the labs, for example. Okay. So that's it. I think, I hope we've covered everything. If you guys have questions, definitely get in touch. I'm hoping to actually have some remote office hours before the semester begins, so watch for those. I will get those posted. I'll send out an email notification too. So watch your emails on Canvas. Watch for any kind of notifications. Pay attention to those. Don't forget about notifications coming in through Canvas. And take a look through Canvas so you can see what is there, all the resources are going to be available to you there. So again, welcome to Physics 4A. I think we're going to have a lot of fun. Physics 4A is a really interesting, fun, surprising, exciting course. Let me know what questions you've got, and I'm here ready to help you get through the course successfully.